Um, Hello class. Right now we'd like to go over the rest of the vacation assignment. So let's get started. So here we realize that y is equal to cosine square 3x. Now if you wanted to look at this one a little bit differently, then you can write it this way: cosine of 3x whole thing squared up. Then it might be a bit easier for you to look at it this way. Now if it continues, then what's going to be happening is this. By the power rule, we'll realize y prime is equal to 2 cosine of 3x. Now, second layer, by the chain rule, we have to take the derivative of cosine, which will be negative sine of 3x. And here comes the third layer, derivative of 3x becomes simply 3. Now, when you combine them together, we'll end up getting negative 6 cosine of 3x times sine of 3x. That becomes our answer, which is choice A. All right. Let us move on to the second question. The derivative of this obtains its maximum value. Now, maximum, simply, in this case, we can realize that we have to take the derivative and set it equal to 0, just like any other times. Then f prime here becomes 4x cubed over 3 minus 5 comes down, cancels out the denominator 5, we will have x to the 4th. Now we realize that x to the 3rd is common, so we can simply write it as x to the 3rd. Now we have 4 over 3 minus x. Then we have two values here where the slope will be equal to 0. I mean, then first one will be when x equals 0, and the second one will be when x equals 4 over 3. Now, if you were to draw the number line, we will end up getting something like this. We will have here 0. Here we have 4 over 3. Now, remembering from the pre-calc, one thing that which we can say is, hey, this one is a triple root. This one is the linear root, linear factor. So due to multiplicity, we will have 3 right here. Now, but normally for quartic, the fourth degree function would have looked something like this, or like this. Now, then, but in this case, due to the triple, and then since the leading coefficient is negative, what we would have gotten is something like this, coming down. So therefore, this portion must be negative, and this portion must be positive. This portion must be negative. Or you can do the sign analysis. Pick the one negative number between these two, such as 1, and then after 4 over 3, such as 2, then you will realize the same thing here. Since the maximum only happens from positive to negative, then our answer will be 4 over 3. Next, suppose that f is a function that is defined for all numbers, which of the following condition assures that f has inverse function. This is from a pre-calculus class. Now, if it's periodic, when you take the inverse function, it's not going to be a function. So think of a sine of x. We have to eliminate a whole bunch of the range in our domain in order for us to get this one done. So A is not the answer. Symmetric with y-axis, once again, it's not going to work out. We can think of y equals x squared, such as that would have been one case. Concave up. Concave up, I can use this one for this argument and also this argument. All right, those things cannot be done either. Now, function is strictly increasing. That makes sense. Strictly increasing. That means whenever we have the function, it's just going to keep on increasing. Whatever the concavity would have been, just keep on increasing no matter what. So therefore, in this case, we will have inverse function also. So therefore the answer will be choice D. All right, here we are looking for concave up. That means concavity, double derivative. So let's get the first derivative. Is 15 x to the fourth minus 60 x squared. Now, second derivative on this one now becomes 60 x to the third. Now here we have minus 120 x. Now, of course, there's something that's common here is 60 x. Then we will have x squared minus 2. Then we will realize that the values that satisfy this one would have been x has to be 0 coming from here, and here we will get x has to be plus or minus radical 2. Now, if you use the number line, we have one negative number, 0, and radical 2. Now, notice, uh, concave up, that means the second derivative has to be positive. How can we have second derivative be positive? But when you look at the second derivative function, because it's a cubic, if you were to graph it, it would have been something like this. Cubic with the leading positive leading coefficient, it would have looked something in this way, right side up. So if I have to follow that, something like that would have been the graph of the concavity. The graph of the second derivative, and then we are looking for portions that's positive. That means right here, and then here. So therefore, the answer should be negative 2 to negative radical 2 to 0, or radical 2 and higher, which will be choice B. Now, next. Haha, this one looks somewhat difficult, but if you think about it carefully, notice that they use the letter H. It's quite interesting because here we have limit. As H approaches 0, just like any other definition of derivative, we have ln 2 plus h over 2 whole thing over h. That's how we can write it, of 1 over h. Now, but in case of logarithm, the division is like subtraction. So we have the limit of ln of 2 plus h minus ln of 2 whole thing over h as h approaches 0. Now, this one here should look more familiar to you. So in this case, we realize f of x function that which we are looking at must be ln of x, where x, the expression is f prime of 2. Now, but in this case, f of x is ln of x, then we realize f prime becomes simply 1 over x. Therefore, f prime of 2 should be equal to 1 over 2. That is our answer right here, choice C. Now let's go for one more. Now, what is the range of f? Now, given in this case, angle, since the x can be any number, while x goes from any while x goes any number, the angle can be anywhere also, because arc tangent talks about simply angle for 0. Angle here could be anywhere from 0 through 90, or anything for that matter. Now, when that happens, the range, the cosine value, will go from -1 to +1. Now, the -1 to +1, then we have this option and also this option. Are we going to include -1? or 1 for that matter. Now, in order for cosine to be equal to 1, in order for cosine to be equal to 1, the angle has to be equal to 0. Now, that means, can we have angle for tangent to be equal to 0? Yes, we can. So therefore, our answer will be choice B. Now here, the word increasing, it seems like we're talking about related wage. Now radius of R of the sphere, radius is increasing at this rate, and then at that surface area. Now we need to figure out the surface area formula, which is right here. Becomes 100 pi square inches. What is the rate of increase in cubic inches? Oh, wait a minute, for the volume. So ultimately what we're looking for is this formula. How does volume changes as the radius changes? So we realize V prime is equal to 4 over 3 pi r squared times 3 by the power rule. 3 comes out, and then r squared times r prime. Now, here we know what r prime was because it was 0.3, but what is r? R, in fact, we can find it from surface area. Since surface area is equal to 4 pi r squared, where surface area was equal to 100 pi, equals 4 pi r squared. And pi cancels out. When you divide by 4, interestingly enough, we get r squared is equal to 25. That means r is equal to 5. So let's put everything onto here. So v prime now is equal to 4 over 3 pi 5 squared times 3 times r prime was equal to 0.3. When you combine everything together, 3 and then cancels out. 4 times 5 squared becomes 100. 100 times 0.3 becomes simply 30 pi. So therefore our answer becomes choice E. Right, we'll continue in part